So, once again, welcome back to our tutorial discussion or review discussion. And as I said earlier, that for this discussion, I will be dividing this into two parts. The first part a while ago was all about when the polynomial is a quadratic polynomial, where the purpose is to solve for the zeros or the values of x. And this time, let's proceed, or I am welcoming you on to the second part. And we're still on the zeros or the values of x or the factors of the polynomial functions. Or simply, the purpose is to solve for the zeros or the values of x and the factors of the given polynomial. And as I mentioned earlier, that for the second part, we will be considering or focusing the polynomial where the degree of that polynomial is higher than 2. Like for example, the degree is 3 or 4 or 5 and higher than 5. So this part here, the focus is, the focus will help you or will guide you how to solve for zeros, values of x, as well as the factors when the polynomial degree or when the degree of the polynomial is higher than or bigger than 2. Okay, for example, let us try to solve for the zeros, the values of x, as well as the factors of the given polynomial function. And the given here is p of x equals x raised to the power of 5 plus 3x raised to the power of 4 minus 5x raised to the power of 3 minus 15x squared plus 4x plus 12. And there is no given binomial considered as divisor or the expression that will give you the idea how to solve for zeros or values of x. So just simply, in a given like this, the easiest way to solve for zeros, values of x, as well as the factor or factors is by using the synthetic method. Again, to recall, when we say synthetic method, we are going to use only the numerical coefficients of the given polynomial function as well as the constant term or the constant part. So, since the numerical coefficients are the only part of the terms of the polynomial that we will be using, so let's start listing down these coefficients. So for the first term, the numerical coefficient is positive 1. And for the second term, we have positive 3 if it is plus. And the third term, the coefficient is negative 5 if it is minus. For the fourth term, we have negative 15. And the fifth term, we have positive 4. And the constant part is positive 12 since it is plus. Consider this as your synthetic dividend. And your next problem now is, what is your synthetic divisor here? For you to continue the process on how to solve for zeros or values of x with the use of synthetic method. So since we need a certain integer or synthetic divisor here, the next thing that we're going to do is, for the last digit, which is the constant part, if it is positive, that is automatic 12. What we're going to do is to try to get all the possible factors of 12. So first, for the 12, you may have 12 times 1, or positive 12 times positive 1, the result is positive 12. And another one, you may say negative 12 times negative 1 is also positive 12. And then you may also consider 6 times 2, that is equal to 12. Or negative 6 times negative 2, that is still equal to 12. And you may also consider 4 or positive 4 times 3 or negative 4 times negative 3. And these are the possible factors of 12, and we can say that these are the complete factors of positive 12. And among these factors are integers, which can be considered the values of x or zeros of this given polynomial. Next thing that you need to remember is that if the degree is 5, automatically there are 5 values of x that you need to determine. While ago, during our first part of the tutorial discussion, if the degree is 2, like quadratic, there are automatically 2 values of x. While this one, again, also, the same is true here, that if the degree is 5, then automatically again, basically, there are 5 possible values that you need to determine. You need to find out as the values of x of this given polynomial function or expression, the right side of the function. Okay, let's begin. So this is what we call the trial and error method when we use synthetic division, because you have to try all the possible factors that will satisfy the given method. Next thing that you need to remember also to save time is that if, since I've mentioned that there are 5 possible values of x because the degree is 5, try to analyze here so that it will not be a waste of time for you to include all possible factors here. Try to drop some of the integers here. When you say drop, try to remove from the choices. So, for example, if the last digit is 12, it means that when you have the 5 different values or 5 values of x here, and when you multiply these 5 values, this will give you the product of 12. So that means it is not ideal or wise to include 12 as one of the values of x, because 12 is just one value and it is automatically the last digit of the function. So that means you need to drop or remove 12 as one of the possible values of x. Next, if you would consider 6, as among the values of x, again, there are 5 basically values of x that you may or you need to determine here because of the degree is 5. If you would consider 6 as one of the values here, that means that for you to get the product, 6, you only have to multiply that one with 2. Not by 6, not by 4, not by 4. Because the result, when you multiply 6 and 6, that is 36. And when you multiply 6 and 4, that will give you 24. Bigger than the last digit, which is equal to 12. So that means you have to drop also this 6 and 6. And next, if you try to consider 4, 4 as among the values of x, here, again remember there are 5 different values basically that you need to determine. So if you consider one of those values is 4, and then you only have 3 or 2 or 1 to multiply um, these values so that the resulting is 12. And then you will say, if you would consider 4 as among the x, so you only have to determine other possible values, 4 possible values like 1, 1, and perhaps you have 2 and you have 2. So if you multiply these 5 numbers here, 4 times 1 is 4 times 1 is 4 times 2 is 8 times 2 is 16. So the resulting possible product is higher than the last digit, which is equal to 12. So that means there is a big chance that 4 and 4 will not be among the 5 values that you need to determine. After dropping the possible values that could not be considered or which could not be considered as values of x, it is now time to try using these values here, smaller factors of 12. So let's begin here. Supposedly, you try positive 1 as your expected values of x. And this is now considered as synthetic divisor. Okay, so just simply, based on our previous lesson tutorial discussion, and the first step when we use the synthetic division or method is just bring down the first term here. That is 1. Then after that, multiply to the synthetic divisor. The result is 1 and place that 1 here. Then add. This is 4 and then repeat the process. That is 4 times 1 is 4. And then add these 2. The result is negative 1. Multiply negative 1 and positive 1. This will be negative. This will be negative. Okay, this will be negative 1. And try to add, this will be negative 16. And then multiply negative 16 and 1. The result is negative 16. And then add 4, positive 4 and negative 16. The result is negative 12. And then negative 12 times positive 1. The result is negative 12. And then add the last part, so the result is 0. When the last part, considered as remainder, is equal to 0, then you can conclude that x is equal to 1 is exactly one of the values that we are looking for. So that means you have now one of the values of x which is equal to positive 1. And then after that, you try to use again the positive 1 because there is a tendency that in one polynomial, 2 the same numbers are used as the value, as values. And then the same, bring down, and 1 times 1, that is 1, and then add, this is 5, 5 times 1, this is 5, add, this is positive 4, and then try to multiply these 2, 4 and 1, the result is 4, and add, this is negative 12, when you multiply negative 12 and 1, the result is negative 12, so when you add, this is negative 24, so the remainder is not 0. So when the remainder or the last digit is not equal to 0, that means the integer that you are using here is not what we are looking for as the next value of x. So this is why this is considered trial and error. You proceed to the next one, which is negative 1 this time. So bring down, then 1 times negative 1 equals negative 1. Add, this will be positive 3. Multiply it to negative 1, the result is negative 3. And add, this will be negative 4. multiply, this will be positive 4, multiplying to the same signs. And then add, this will be negative 12. Multiply negative 12 and negative 1, the result is positive 12. So add, the result is 0. So since the remainder is 0, or the last digit of our sum is 0, therefore you can conclude that negative 1 is the next value of x that we are looking for. So you have negative 1. So there are 3 more values that you need to look for. And then perhaps you will proceed to positive 2. For example, positive 2 here. From 1, negative 1, and then positive 2. And then bring down 1, multiply, this is 2. And then add, this is 5. And then multiply, this is positive 10. Okay, multiply 5 and 2, that is positive 10. Add, that is 6. Negative 4 plus 10 equals positive 6. And multiply 6 and 2, the result is positive 12. And when you add, the result is 0. So therefore, the third value of x is equal to positive 2. You have here x is equal to positive 2. And perhaps you proceed to the next. You may consider this time the negative 2 as a possible value of x. And then just repeat the process, which is equal to negative. Bring down 1 and then multiply. This is negative 2. Add, this is positive 3. And multiply 3 and negative 2, that is negative 6. So the result is 0. So therefore, x is equal to negative 2, or negative 2 is the next value of x here in that given polynomial. And the last one, we have positive 3. Let's try positive 3. You have here, you have positive, bring down positive 1, you have here, and then 1 times 3, this is 3. When you add, that is 6. So that means, since the last digit is not equal to 0 here, that means positive 3 is not the last value that we need to consider. And you may use this time negative 3. And then the same, bring down 1, you have 1 times negative 3, that is negative 3. So when you add that, the sum is equal to 0. So therefore, the last value for the value x for that given polynomial is negative 3. So we have now 1, 2, 3, 4, 5. So these are the 5 different values, or 5 values of x that we need to look for, or that we need in order to satisfy that these integers are the values of x needed for us in order to satisfy the given function. And that means also that when we try to graph this given polynomial, the graph of this will pass through the x-axis, where x is equal to 1, negative 1, and positive 2, and negative 2, and negative 3. So, how are you going to rewrite this one into factors? Because that method is also very useful when you try to factor out the given polynomial. The same method is used when you try to solve for the values of x. So for x is equal to 1, your factor is equal to x minus 1. Simply, you are just trying to transpose 1 to the left side, so that becomes minus. And the other one, you have x plus 1 for the x minus 1. And the factor form of x equals positive 2, you have x minus 2. And for the x plus x equals negative 2, the factor form will be x plus 2. And for x equals negative 3, the factor form is equal to x plus positive 3. These are the values of x that when we try to substitute these values into the given polynomial function, the result, the end part, becomes 0. So that is why these values of x are also considered zeros of this given polynomial. Because again, when we substitute this one by one into the given function, the result in relation to remainder theorem is equal to 0. That is why, aside from these are values of x, these are also zeros of that given polynomial. Again, the purpose for the values of x is for you to see, to determine which part of the x-axis that the graph of this polynomial will pass through. And that might be our lesson next meeting when we continue with our review lesson. And for this time, the focus is only to solve for zeros values of x and the factor form of this given polynomial. So, if you find it confusing, just try to replay and to review the discussion once, or if this will be uploaded in my channel. And if you need to raise questions, you can comment your questions and you can ask me directly. So that's it for today, and I hope this will help you again for you to have your review lesson in relation to your regular mathematics class discussion. So thank you so much and have a great day.